Billions of dollars are flowing into enterprise AI initiatives, yet the actual returns rarely match the initial enthusiasm. This Gartner research highlights the gap. Only 28% of AI projects deliver a measurable return on investment, while roughly 60% are projected for abandonment. These failures usually stem from a fundamental mismatch in management methodology that persists regardless of a team's technical coding or prompt engineering skill. Teams often default to the CRISP-DM framework, a process methodology originally designed in 1999 for static data mining tasks. Applying a decades-old data exploration tool to a live generative AI deployment creates immediate operational blind spots. Traditional software project management assumes deterministic outcomes. You write fixed rules, input the data, and expect a predictable result every time. AI systems function differently. Instead of a single output, they are inherently stochastic, yielding a bell curve of probable results. This breaks traditional testing. On the left, a rigid test fails without an exact match. On the right, the result passes if it falls within an acceptable statistical threshold. Ignoring this probabilistic reality leads directly to models behaving unpredictably once they are exposed to live production data. Managing AI effectively requires moving past the illusion of perfect predictability to adopt frameworks designed for uncertainty. We can see where legacy processes break down by comparing them directly against modern alternatives. This comparison matrix shows that CRISP-DM explicitly defines 0 team roles and offers no guidance for what happens after a model is deployed. Microsoft's Team Data Science Process, or TDSP, fills this gap by defining 4 distinct tiers of team roles, from group managers down to individual contributors. Because AI development is distributed across data engineers, scientists, and app developers, a strict RACI matrix is necessary to prevent handoff failures between these disciplines. Without clear accountability, AI initiatives usually devolve into isolated science experiments rather than integrated products. The consequences of operating without these formal gates are increasingly visible in both corporate balance sheets and legal transcripts. In 2021, Zello took an $881 million loss when their pricing model failed to adapt to a shift in market dynamics, a classic case of unchecked concept drift. Air Canada faced similar liability after their customer service chatbot fabricated a bereavement fare policy that the company was then legally forced to honor. The CPMAI framework addresses these risks by requiring an explicit AI go-no-go decision during the initial business understanding phase. Incorporating these governance gates intentionally slows down the planning phase, but it serves as a necessary defense against catastrophic legal and financial exposure. Moving beyond manual experiments requires a significant upgrade to operational infrastructure. In standard software, DevOps focuses on the continuous integration and deployment of code. This comparison table shows that MLOps expands that scope. You must simultaneously version the Holy Trinity: code, data, and the models themselves. The MLOps column includes a pillar with no DevOps equivalent, continuous training, or CT. To prevent accuracy decay, a system must actively monitor for drift and automatically trigger this retraining cycle when real-world inputs shift. You can validate these retrained models by using canary releases to test with small shares of live traffic, or shadow deployments to log predictions without showing them to users. MLOps moves a model from a static state into a self-correcting cycle that updates as new data arrives, maintaining its business value over time. Not every project requires the heavy engineering overhead of a full MLOps pipeline. This matrix helps determine the right framework by mapping complexity against risk. For low-risk internal tasks, the legacy CRISP-DM process is a valid, lightweight choice. However, live systems touching users or revenue mandate CPMAI or TDSP alongside full MLOps infrastructure. Mismatching these frameworks to the project's actual risk level results in either dangerous exposure or unnecessary bureaucratic drag. Successfully adopting AI ultimately depends on the human at the center of the project and their ability to navigate a fundamental change in perspective. This graphic outlines the necessary transition from a deterministic mindset to a probabilistic one, acknowledging that AI outcomes are inherently variable. Harvard Business Review research indicates that rigorous product management discipline, rather than technical prompting skill, is the primary driver of AI success. To survive in the real world, AI cannot be treated as a finite project with a fixed end date. It is a living product that requires continuous governance, measurement, and evolution.